So today, let's learn about independent sample t-test or parametric statistical treatment. So we use an independent sample t-test when we want to compare the means of precisely two groups to determine whether two population means are different. It's like you have a test question for two respondents that takes different drinks and comparing their rating to determine which drink will be highly recommended. This procedure is called inferential statistical hypothesis test, meaning it uses samples to draw conclusions about populations. So the independent sample t-test is also known as two-sample t-test. Remember that t-test requires continuous data. So continuous variables can take on any numeric value and the scale can be meaningfully divided into smaller increments. There are infinite number of possible values between any two values. So typically, you measure continuous variables on a scale. For example, when you are measuring temperature, weight, and height, you have a continuous data. So, for the independent sample t-test, when each group is larger than 15, your data can be mildly skewed and the test result will still be valid. However, if your sample size is less than 15 per group, graph your data and determine whether two population distribution rather are skewed. In this case, you might need to use a non-parametric test, which is Mann-Whitney-U test, that we're going to be tackled in the next video. So Mann-Whitney-U test is a non-parametric test that correspond to the independent sample t-test. So now, for you to completely understand the independent sample t-test, let's run an example. So our hypothetical scenario is that we are comparing pretest scores from two teaching strategies. So we drew two random samples of students. Students in one group learned using strategy 1 while the other group used strategy 2. So these samples contain entirely separate students. So here our research question that we want to determine is, do students who learn strategy 1 have different mean score than those who learn in strategy 2? So let's go to the Excel. So we have here an overall pretest result from two different groups of students where different teaching strategies are applied. In order to get the independent t-test, we're going to the data here. Then go to data analysis. Under the data analysis tool, let's scroll down to find the t-test such as two sample assuming unequal variances. So because we haven't got yet the variance of our data, that's why we can assume that they have an equal variance. So press OK. In the variable 1 range, let's click all the pretest tests of the first strategy, and in variable 2 is the second strategy. Then if you want to see your result in another sheet, just don't change this. But for me, I want to see the result on the same sheet for our convenience, so I will select output range and put it here in G column, then press OK. So as you can see, from the result that the t statistic that we're only going to use in this t stat here, which is 6.321, and the p-value is this two-tailed because in our hypothesis we didn't say that the first strategy should be higher than the second one. And then now we will going to find the standard deviation of each pretest because it needs on interpreting the data. In order to get the standard deviation in this cell, put an equal, then enter std.dev, then select the function with p variable. Then now, we highlight the pretest of strategy 1, then enter. The same process for the other one. enter. There you go. So now, this is how we're going to interpret the data we got. If the p-value is less than our significance level, which is 0.05, I can reject the null hypothesis. The difference between the two means is statistically significant. Our sample provides strong enough evidence to conclude that two population means are not equal. So the mean for strategy 1 is 7.33 and for strategy 2 is 5.33. Looking in the standard deviation column, we can see that they are not exactly equal, but they are close enough to assume equal variances. Because the p-value is 0.00023 for our independent samples t-test is less than the standard significance level of 0.05, we can reject the null hypothesis. If the p-value is low, the null must go. Our sample data support the claims that the population means are different. So specifically, the first strategy mean is greater than second strategy mean. If high score are better, then strategy 1 is significantly better than strategy 2. So that's all. Hope you guys learned something about the independent sample t-test. Let's see you again in the next video. God bless you all.